Math 3 Lesson Summary Video. Sign on the dotted line. This lesson is a practice understanding task, which takes concepts you have been working on and applies them to new situations. The purpose of this lesson is to connect all that you have learned about rational functions so far to sketch the graph of a rational function. We're going to start with a graph or an equation that has already been factored for us. Don't forget, a theme for rational functions is factor first. Just about everything we need to do is easier if it's in factored form. So to graph, we always want to start looking for key features, things like x and y intercepts, where are the asymptotes, what is the end behavior. This is all the pieces that we put together to make the graph. So as we look at this equation, you'll notice that I have a vertical asymptote at x equals -2. Don't forget, it's the denominator that tells us what the restrictions are on the domain. So we can't let these equal 0, so I can't let x equal 2, and I can't let x equal -2. So that's going to give me my vertical asymptotes at x equals -2 and x equals 2. Asymptotes give us the framework of our graph, so that's always a great place to start. Now don't forget, asymptotes aren't really the graph. We don't want to use solid lines for those. They're not where the actual points on the graph are, but they are the framework. So putting a dashed line or a little mark with your highlighter, something to let you know that I'm not supposed to let my graph touch these lines. So I have a vertical asymptote and a horizontal asymptote to look for. So let's look for our horizontal asymptote. We have to know our degrees for that one. So this is in factored form, so don't forget, you do need to multiply it out to figure out what its degree is. This is going to be x squared. So this is a degree of 2 on the top. This is also going to be x squared. So it's a degree of 2 on the bottom. So if it's a degree of 2 on the top and a degree of 2 on the bottom, then they have the same degree. And we learned when they have the same degree that we just need to take the leading coefficients and find their ratio. So this is a leading coefficient of 1 and a leading coefficient of 1. 1 divided by 1 is just 1. So we're going to have a horizontal asymptote at y equals 1. So again, it's just an asymptote, so I'm just going to mark it ever so slightly. So now I have this framework for my graph. I have broken my grid up into 6 pieces. I have 1, 2, 3 spaces up here and 1, 2, 3 spaces down here. And now it's figuring out which of these 3 spaces actually have graph in them. So when we want to start looking for that, x and y intercepts are a great place to start. It doesn't always answer all of our questions, but it can give us a great place to jump off at. So x-intercepts are where the numerator is equal to 0. So that's going to be x equals 5 and x equals -1. So I can go on my graph to 5. I'm going to have an x-intercept on the x-axis right here. And -1 is going to give me one right here. All right, so now we have our x-intercepts. Y-intercepts, we just need to plug 0 in, or substitute. We say substitute 0 in for x. So that would give me -5 times 1, which is just -5, and 2 times -2, which is -4. Negative divided by negative is positive 5/4. So we have an x-intercepts at 5 and -1, and our y-intercept is going to be at 5/4, which for graphing purposes is 1.25. So 1 and a little bit more than that. All right. So what we know is that I can't cross the asymptotes, the vertical asymptotes, over on this side. So it's going to go from this x-intercept, and it's going to come down, and it's going to get closer and closer to that vertical asymptote and not cross it. The horizontal asymptotes give us end behavior. So at the end of the graph, you can't cross over it. So this is the end of the graph, and so it must be approaching this asymptote and going this way. In the middle, you can't cross vertical asymptotes ever because they're not part of the domain. But in the middle, the horizontal asymptote doesn't trap the graph necessarily because the horizontal asymptote gives us end behavior, not middle behavior. And so you can cross the horizontal asymptote in the middle because all it's having an effect on is the end of the graph. And we could tell that that was the case here because notice that our x-intercept was below the horizontal asymptote, but our y-intercept was above it. And so as it goes this way, it's going up because it went up from this point to this point. And as it goes up this way, it's going to get closer to the asymptote. And as it goes down over to this other side, it's going to get closer to the asymptote. So we get this shape here in the middle. Our only problem was we didn't get any points over on this side of the graph. We need to know whether we have something going on up here or do we have something going on between the asymptotes on this side. So you just sometimes have to pick a point. I'm going to pick -5 because it's right here kind of in the middle of this section. That should give me a good idea of where I'm supposed to be. So I'm going to substitute -5 into the problem. So -5 minus 5 would be -10. -5 plus 1 would be -4. -5 plus 2 is -3. And -5 minus 2 is -7. So on the top, I'm going to have 40. On the bottom, I'm going to have 21. And 40 divided by 21 is just under 2. If this had been 20, it would have been exactly 2. So this is 21. So it looks like it's going to be just barely under 2, 1.9, 1.8 something right here. And that tells me I'm in this upper quadrant up here in this corner. So I did not end up down here. I can't cross the horizontal asymptote out here because this is the end behavior. I can't cross the vertical asymptote ever. And so I'm just going to get closer and closer to my asymptotes from that point and get a nice little curve. So we end up with a curve in this upper quadrant, a nice almost cubic looking curve in the middle, and a curve in this outside corner. So concentrate on your key features. Many times your key features will give you everything you need. In this case, we needed one more point to help us out to figure out what was going on this side. And so we just substituted some x value from that area of the graph so that we could figure out which side of that horizontal asymptote we were supposed to be on. And then we were able to get the picture of our graph. Let's take a look at the next graph. Now, as you are dealing with graphs, one of the things that you want to realize is that all of the things we learned about finding key features were for one rational expression. And this one has two. And so we don't actually have any rules for finding the parts of the graph when it's two rational expressions instead of one, which means that our first job is always going to get one rational expression. So if there's something being added or subtracted, we are always going to have to do that operation to combine them into one rational expression. So this is addition. This is why we went over operations with rational expressions, because sometimes we need to actually combine the rational expressions to figure out what's going on with this function. So we're going to need a common denominator that has both x minus 3 and x plus 1. So as I find my common denominator, I'm going to have to multiply the top and the bottom by x minus 3. And this one needs the x plus 1. So we only want to multiply by 1, remember? So we have to make sure we do the same thing on the numerator and the denominator. So up in the top, we're going to have 4x minus 12 plus, now this one I don't want to forget to do my double distribution, so I'm going to have x squared, positive 1x, and negative 5x is negative 4x, and negative 5 times 1 is negative 5. So that's going to be my numerator, and our common denominator we want to leave factored we were going to need it factored anyway to figure out what our key features were, so might as well leave it that way and not give myself extra work. We do need to simplify this, see if it will factor. These are the things that we need to look for. So I'm going to have x squared, positive 4x, and negative 4x conveniently cancel. So that's pretty awesome. Negative 12 and negative 5 is negative 17. So now we have a rational expression that we can actually work with for this function to find our x-intercepts, our y-intercepts, and all of the fun things that go along with those. So let's start with our asymptotes. Let's figure out our vertical asymptotes. We have two things in the denominator that would make it equal to 0. X if it was negative 1, so we can't allow that to happen, and x if it was 3. Negative 1 would give us 0, 3 would give us 0, so we have to take those out of the equation. So negative 1 is here. So we want to get an asymptote here to keep us from going there. And 3 is here. So we'll get a vertical asymptote to keep us safe there. Horizontal asymptote, we want to look at our degrees. So I have a degree of 2 on the top. And again, if we multiply this out, we'll have x squared on the bottom as well. So it is also a degree of 2. When your degrees are the same, it's the ratio of those leading coefficients. So 1 divided by 1 is going to give us a horizontal asymptote again at 1. So we can have that horizontal asymptote here to keep us in the ends going where we're supposed to go. Now let's look at these x-intercepts and y-intercepts. X-intercepts are where the numerator is equal to 0. So x squared minus 17 equals 0 will give me x squared equals 17. And when I take the square root, don't forget to get both of those outputs. So it could be plus or minus the square root of 17. So don't be put off by this square root. We're graphing, so having a decimal approximation totally makes sense. 4 squared is 16, so this is actually pretty close to 16. So it's going to be 4 and just a itty bit more, just 4 and a little bit more. And it's going to be positive or negative. So I have an x-intercept at 4 and a little bit, negative 4 and a little bit, and at positive 4 and a little bit. So that gives me this corner and this corner. I know as I'm going to the ends, I can only approach that asymptote. And as I come down on this side, I'm going to approach my vertical asymptote. On this side, I'm going to approach that horizontal asymptote. And I'm going to approach the vertical asymptote. So that actually gave us 2 of ours. Now remember, it's a function, so I can't have something up here on top of it. I can't have something over here on top of it. That would give us 2 outputs. So these sections are done. We just need to figure out what's going on in this middle section, and the y-axis happens to be in that middle section. So a y-intercept should help us figure out which side of the graph we're on. When I have a y-intercept, we just want to substitute 0 in for x. So 0 would give me negative 17 in the numerator, and in the denominator, I'm going to have 1 times negative 3. So I end up with negative 17 over negative 3, which is going to be positive approximately 5.8-ish, 9-ish. It's not quite 18, it's not quite 6. So I have a y-intercept up here at 5, not quite 6. Now, our only real question here is, can it cross the horizontal asymptote? One of the things that you will notice is that our graphs like to, these rational expressions like to alternate back and forth a lot. So if these two were both in the bottom below the asymptote, the horizontal asymptote, I have a feeling this one's going to stay on the top. However, I do want to just double check. So to make myself feel better, I can always pick another point in this section and see whether it stays above the asymptote or does it go below the asymptote. So I'm going to choose 2. If I put 2 in, if I substitute 2 in, I get 4 minus 17, which is negative 13. 2 plus 1 is 3, and 2 minus 3 is negative 1. So when I do this, I get negative 13 divided by negative 3, which is going to be 4 point something, 4.3-ish, around that general area. So 2 is going to be 4 and about 1/3. So it does look like, in fact, this stays above. So it's going to be, come down. It's never a bad idea to pick another point. Picking 1 would tell us kind of exactly where in here do I need to turn my graph around, but it does not cross the horizontal asymptote.